Okay, so as I was saying, we were doing uh, wait a minute. Okay. We were looking at how things go together, particularly about ions. This is a way for you to practice your ion naming and formula writing skills. We'll get to the actual chemistry of what is going on there with um, uh, the reactions later. But the point is mostly, can you read the formulas that are given there? Do you know those metals? Do you know those polyatomic ions? And can you then search for them and see if they will make a precipitate or not? But what I'd like to do is I'd like to kind of show you as an example how to do that um, on Thursday and Friday. Both of those days, I was ready to do so, but I figured they'll ask for it if they need the help. So, but over the weekend, somebody did ask for help, and so you're going to get some help now. So the thing is, if you open up your form, you should, and let me just go ahead and pull over the classroom for this period. Okay. There's nothing new today, and I just now remembered as well to announce that tomorrow is no class, no work. Tomorrow is the SAT, and so it is going to be not exactly a day off because you may still have things that you need to work on, but there won't be anything posted tomorrow that is due tomorrow, if that makes sense.
I told my friend from work that there was not necessarily school tomorrow, but like we'll have work, and now I'm working 10 to 2.
Right, right. I'm not in, nothing from me anyway. Will you have to do tomorrow, if that makes sense?
Just your class or every class?
I can't speak for other teachers.
Are we having classes for everything?
There will be no classes in the afternoon as well. Okay, the office hour times for third and fourth hour that you might normally have, you don't tomorrow. Now again, this is my understanding. I can't speak for your third and fourth hour teachers as far as the afternoon goes, but I know for sure in the morning you should not be doing any meetings, no computer times. It should be time here for the SAT if you're here for the SAT, or I mean, catch up on whatever else you need to do. So, and if that means, you know, learning how the world works with a job, then that's what you're doing. So Wednesday and you know the rest of the week is back to normal, and then we have a new normal starting next Monday with the full days. So again, it's too late now to come back if you wanted to. Unfortunately, unless you signed up earlier, but you can't sign up now. But I am looking forward to a couple of you coming back anyway next Monday, and I really, you know, I am sorry for those of you who will be on the computer all day on 4 days a week. But the good news is you'll be at home. You can open up your window, maybe have some fresh air, take your device outside. I don't know, sit on the grass. So there are some advantages. Disadvantages, of course, are, I think, obvious, so I won't go into those. So now, back to what I was talking about before. I want to go ahead and share with you what you saw last Friday. No, we'll start with Thursday. We'll start with Thursday. Okay. And again, during class, I didn't really get a lot of questions about this. I know not all of you answered it. So please do ask. Please do ask. All right. So that's a little bit small on the screen, so let me embiggen it. One of those words that the Simpsons added to the dictionary. Okay, so you have your usual hour and last name. Now I'd say for each of these 4 questions, they're all the same direction. It's just, and also the same 6 chemicals horizontally. The only difference is that the one on the left is different. The one on the left is different. Now, if you see here at the top, it says page 295, and you all should have your textbook. There's one student in 7th hour who doesn't have their textbook, hasn't picked it up, but that doesn't apply to any of you. You all should have your chemistry textbook either at home, well, it should be at home at this point, because the adaptive pause and everything, they all got taken home. Taken, that's another bad word. Anyway, taken home. So anyway, so page 295, if you look at that, the purpose in the book is to observe the formation of compounds. However, you can't observe it because you're not actually mixing these 10 things, 6 in one hand and 4 in the other, to make a total of 24 combinations. You're going to use the internet to find out which combinations of ionic compounds form precipitates. So this is where Google comes in. You can use other search engines. You know, there are other search engines. There's Bing. There's Yahoo. There's DuckDuckGo. There are a lot of others, but you know, Google is sort of the default. All right, remember the numbers that follow letters are subscripts. So for instance, down here, AgNO3, that means there are 3 oxygens, not 3 NOs, okay, that's 3 oxygens. But over here, outside the parentheses, there are 2 NO3s. So I know that there's no subscripts in a Google form, and that's why I wanted to remind you of that. So part of this exercise is to see, are you reading well? Can you interpret what these formulas are into words so you can Google for them, or at least move them around in your head to know what's going to be made. So let's start at the beginning here. We have AgNO3 and Na2CO3. Now, the direction here is check the boxes that do form precipitates according to your research. So I've got AgNO3 and Na2CO3. And I never explicitly said this, but all 10 of these chemicals, the 6 that go across, you know, like if, 6 columns here, and they're always the same, all 4 questions, and the 4 that go down the side, and again, it's exactly what's in the book. If you look on page 295, it's exact same chemicals, exact same order. They all do dissolve in water to start with. So there's no tricks here like, haha, you know, calcium chloride doesn't dissolve. They will all dissolve. They will all make a solution. Some of them might have a color, but they should all be fairly clear. And what that means is they're completely dissolved. And so they're ready to react. They're ready to meet up with a new friend and maybe settle down and precipitate out, and that means make a solid. Because what happens is, in most ionic compounds, or at least in many, water will pull them apart. They are not as strongly attracted to each other as they are maybe to the oxygen of water for the positive ions, or the hydrogen of water for the negative ions. They would rather actually be surrounded by waters than stay in their crystals. You take away the waters, they make a crystal again, yeah, water really does like ions. It's very polar molecule. So anyway, these ones will all break apart. But the question is, when I mix these 2 together, what do I get? I don't automatically know. I don't automatically know from using the periodic table or the trends or, you know, the electron configurations or anything like that. I don't automatically know if it will. I have to do research, which takes the place of an experiment right now. So what I do is I think here, okay, I have silver for this cation, and I have sodium for that cation. I have nitrate for this anion, and carbonate for this anion. I need to know these things. I know Ag is silver. I need to know CO3 is carbonate. I need to know those things. So when I mix them together, if I make more silver nitrate, well, it's already dissolved. I know that won't make a precipitate. If I make more sodium carbonate, that's already dissolved. It's not going to make more precipitate. So only if I swap things, crisscross the ions, those are the only things that could make a precipitate. So I'm going to take sodium and nitrate and see is, sorry, looking at here, okay. Does sodium nitrate dissolve in water? See, other people have already asked this question. All right. And I don't just click on the first thing because I got videos here. I could go over to the little Wikipedia column here. Okay. Again, Google is not my source. I still need to go to the actual sodium nitrite. I don't want nitrite. I want nitrate. Anyway, let's see here. Oh, there we go. Sodium nitrate. Sodium nitrate. And again, that's pretty small, so let me make it bigger. All right, sodium nitrate is the chemical compound with the formula NaNO3, okay? And it's chili saltpeter. Okay, I don't need to know that. It's very soluble in water. Okay, so it's going to dissolve. It will not make a precipitate. And it goes on to tell you a lot of other interesting things about sodium nitrate. So I know when I go back to my form, I know that anytime I have sodium and nitrate, okay, sodium and nitrate, anytime I do that, that will not make a precipitate. So I have to look at the other thing, okay? I have to look at the silver and the carbonate. Okay, so how about silver carbonate? It's okay to use Wikipedia. Silver carbonate. Okay, so just to confirm, it is Ag2CO3. It's yellow, kind of grayish, kind of ugly, looks like mashed avocado. Don't eat it. Poorly soluble in water. Oh, poorly soluble. So it will make a precipitate. Let me just look for the word precipitate, though, because soluble wasn't actually in the directions. But let's see here. Right. It's going to be very insoluble. Right, these are very small numbers. Very small numbers. Again, you haven't done a lot of exercises with these numbers, but let me tell you that grams per liter. A liter is pretty big. You know, think about like a liter of soda or something, a 2-liter bottle. It's pretty big. Grams are very, very small, and this isn't even 1 gram. This isn't even 1/10 of a gram. And so, yeah, it's not going to dissolve in water. It's going to make a precipitate. So I go back to my form, and I click check. Then I do that 23 more times. All right. 20. Say again? Silver and carbonates together will make a precipitate, yes. Sodium will not make a precipitate, but it will not prevent the silver from making a precipitate. It won't get in the other way. Okay, we got a question over here. So if it's not soluble, it's a precipitate. That is a very good question. Yes, yes, that is a very important word to add to your vocabulary. Soluble means dissolvable. It doesn't make a solid precipitate. If it is insoluble, you can't make a solution. If it's insoluble, you can't make a solution, and so it makes a precipitate. It falls out. It was floating around in the liquid, but now it's solid. Solids are more dense than liquids, usually, and so they fall down, just like snow or dandruff. So it precipitates down. More questions about that?
So we just break it up.
Right. If you break it up and swap the partners, kind of like a square dance, which you may not have done, but in any case, so here again, I don't need to repeat sodium and nitrate. I don't need to look that up. I just need to look up lead carbonate. So I go back over to my handy Wikipedia. It does not. Okay, what do I mean swap? Okay, so I start here with Pb, which is lead, and nitrate. So my cation is lead, and my anion is nitrate. Then over on the left, I've still got the same other thing. That's going to dissolve in water. All four of these things are going to be floating around in their beakers. And what's going to happen is when I mix the beakers, they're going to find new partners because stuff just moves around. They're going to find new partners. And every time a sodium bumps into a nitrate, it'll just bump right off saying, I'm not interested. But maybe when a lead bumps into a carbonate, then it will fall down. It remains to be seen. Okay, we can't just know in advance. We have to actually do the experiment. Now, again, you're not really doing the experiment. You're seeing what other people did. So soluble equals precipitate. No, insoluble. Insoluble equals precipitate. So. With the subscripts, yeah. All right. So, but sodium and nitrate are not going to precipitate out. Okay, so we established that first. Sodium and nitrate are not going to precipitate. Let me just cut to the chase. Sodium and nothing is going to precipitate, okay? Sodium doesn't precipitate. So all 24 of these, you don't need to look up sodium and any of these anion combinations. Okay, so that's half your work done right now. Sodium and none of these is going to precipitate. But the carbonate with these cations might or might not. The phosphate with these cations might or might not. The hydroxide with these cations might or might not. And the sulfate with these cations might or might not. So you can pretty much ignore the sodium. Okay, you can pretty much ignore the sodium. So if we just look at the cation from the horizontal rows, so silver, lead, calcium, iron 3, magnesium, and copper 2, then, or sorry, lead 2, I didn't see the number there. If I look those up with the carbonate, I'll find a number that is really small. Again, I didn't teach you about solubility. I'm just looking for things on Google. I'm looking for things on Wikipedia. But I'm telling you this important word, soluble. If it is very soluble, there is no precipitate. If it is poorly soluble, it will fall down. It will not dissolve. So see the SOL in soluble and also in dissolve. Okay. That'd be good. See you later, Lauren. All right. Okay. Let's see here. Where was I? Oh, yes. Now we're going to look up lead 2 carbonate. Now, would you like me to look it up on Google or Wikipedia? Any preference?
It don't matter.
All right. Well, I'll tell you what. I prefer Wikipedia personally because while the sources on Google, may be to like a particular university, the nice thing is Wikipedia itself has legit sources, and so I will look this up. Now, it's important too to notice, as you're naming this, there are 2 nitrates. Nitrate is always -1, so it has a total of -1 charge. Lead has to have a +2 charge then to balance it out. It has to have a +2 charge in order for +2 and a couple of -1s. See you later. A couple of -1s to balance up. So if I look over here, I look up lead 2, not nitrate. That's what I started off with, carbonate. Lead 2 carbonate. So it's a thing. Now let's see if it is soluble or insoluble. The white solid, it's toxic. It doesn't say whether in the very first paragraph is it soluble or insoluble. But I can look down at properties. I can look down at properties, and I can look at solubility in water. Oh, that's a really small number here. Again, I don't know if those of you at home can see that, but this isn't even 1,000th of a gram in 100 milliliters. So I guess per liter you just multiply by 10, but it's still a really, really small number. It's insoluble, which means it will make a precipitate. So very small solubility means it will make a precipitate. So the trick here is doing the skills you learned from chapters 8 and 9, where you're naming these things. Okay, you got to know that this is silver. You got to know this is nitrate. You got to know this is sodium and this is carbonate. You got to know this is lead 2. Now, none of these things are covalent. None of them are at least supposed to be acidic or basic. Some of them actually are basic, but never mind about that. But as you look through and you march through these, you'll see, are they soluble? Are they not soluble? So you don't have anything new today, because I think this will still be plenty of work for you to redo if you didn't do it, or if you did do it, to redo again. Yes. That's why I haven't entered any grades yet.
How do you know if that's lead too, or is it just lead too?
Okay. How do I know if it is lead 2? Now let's say I just put in lead carbonate. Okay. Lead carbonate itself is like the only thing that comes up with lead carbonate. So if I forget, oh, is it supposed to be lead 1? Is it lead 4? Like what? If I have memorized my 8s, my nitrate, my carbonate, my phosphate, I will know NO3 is going to be a -1 charge. I've got 2 of those. So I've got 2 that are negative. To balance it, the lead has to be positive 2. I don't know how to make a plus 2. It just has to be, because it has to add up to 0. Okay, so it will be lead 2 nitrate. But if there was a little 4 here, if there were 4 nitrates around the lead, it would be lead 4 nitrate.
Okay, so we just flip that basically
Yeah. Yeah, now I'm not asking you to name them here, but I am asking you over here. Over here, again, just the same as what you did here. You don't have to look them up again, because hopefully at the bottom here, you sent yourself a copy of your responses. So you can look at your responses for the thing from Thursday, for the thing from Friday, write 2 compounds names, your choice. Now, if you notice, there are 4 lines, and you're not supposed to repeat any. So if you, if you've used all 6, plan ahead, okay? So don't, use some of the ones on the left as you go, okay? Yes. Sure.
Would I just be writing what it are, or I'm going to be writing stuff?
You can't write subscripts, but you do need the numbers. So really quickly here before the bell rings, I would say lead 2 nitrate, and let's say sodium carbonate.
So that would be 2.
That would be 2. And it doesn't have to be in a particular order as long as you have these here. You don't have to say what they make, just what they are. Okay? And do remember to go ahead and put in those check marks, where they belong. I know that, it's another step, but checking things shouldn't take too long. I do have to let you go. And I hope that you have a good rest of your day. Enjoy the warm weather. Remember, if you have a score that is D or F, you do need to, come by or I would greatly like it if you came by the thing this afternoon. So I'm not taking off points if you don't, but why not?
After hours?
Yeah, after school stuff. Yeah. All right. Bye bye.